Hello, we're going to talk about radio wave. So radio transmitter. So radio wave transmitter and receiver. So this radio wave, it's part of the EM wave, right? Part of EM wave. So it has the lowest frequency and lowest energy, and it's much less harmful, right? Less harmful for human being due to low energy, right? So that's important aspect of it. So think about it. It could have like 10 to the 4 meter as lambda, right? So this is called wavelengths. So imagine how how long that is. So you can imagine when you have a signal that has a very long wavelength that goes like that, versus another signal that that goes like that. Like this is like the gamma, right? The gamma ray. So it's like, much faster than this, right? Goes like that. And the difference here can be 10 to the, I think it was like a 19 or something, right? So the ratio is very big. So you can see how much more motion, right? So think of it as any particle or any, like your E field and your B field, right? So EM wave has E field and has B field, right? So they need to vibrate, right? They need to kind of like doing back and forth. So there's a lot more motion. You see that? There's a lot more motion, right? And this motion means, motion. It's kind of give you an idea that there's higher energy, right? It's more motion, it's more energy, and so this energy can be very damaging. All right, so that's the a little bit of the radio having a high lambda and a slow frequency, and what's the impact to our body. Okay, now we'll talk about block diagram, the block diagram of a radio transmitter. Okay, block diagram. Okay, so you have a microphone. This is a microphone. Okay, and then you had something that's called amplifier, right? It's called AF. So AF stands for audio frequency. So audio frequency. So this just, like a radio frequency. It's part of the radio frequency here, right? So so audio frequency, it's going from, let's see, the audio frequency, right? The audible frequency. So let's see, the audible frequency, right? For humans' ear, it's about 20 to 20 kilohertz, right? That's the human being, right? For human. All right. And so, but this is, this, we just call it audio frequency. And so this one here, you amplify it. This is an amplifier, right? So you amplifier, and then it comes here, you have a mixer. So you mix two things together. You have a mixer. And what do you mix? You mix this carrier signal. Okay, so this carrier this is referring to the radio station's frequency, right? Radio stations. So for example, 570, right? Radio station 570. What does that mean? It means 570 kilohertz. Okay, so then you have basically this this signal, this constant frequency, right? And the frequency of it is equal to the radio station, right? Radio station, and that's equal to your 570 here, for example. So you mix these two together. So you first you amplify it, you make the amplitude bigger. So you have this signal here, and then you mix it together, and then you have this one here. I'm going to call that one modulated signal, right? Modulated. So the word modulated here means you mix them together, okay? Modulated signal. Okay? Now once you have modulated signal, you amplify it again. So now they call it RF signal now. So we call it radio frequency, right? So this is radio frequency. Radio frequency. All right? Okay? So then you have this modulated signal, this radio frequency amplifier, right? Amplifier. Now you're ready to send it to the transmitter, the radio transmitter. Transmitter. All right, so transmitting antenna here, right? So then you have this guy here, the transmitter here is the antenna. So the transmitter here is the antenna. It's referring to the antenna that we talk about. All right? So then you have this one here, then antenna would then, send out your E field and your B field, right? And then your speed of your radio frequency, radio signal will then go out in the speed of light. 3 times 10 to the 8. All right, so that's the block diagram of a transmitter. And now we're going to talk about the block diagram of a receiver, right? So for the receiver, you have a receiving antenna, okay? So let's say this is the receiving antenna here. The receiving antenna. So this one here, right? So the signal comes here. This is RF signal that comes, and it has this, has the 2 things, right? It has the carrier, so like a 570, for example, kilohertz, and then you mix it with the audio, right? The AF, right? Okay, and you mix them together. You already mix them, right? And then you amplify. So you receive this signal here, and then then this one here says this is an RF signal, radio frequency signal, and then you will go through this demodulator, okay? So basically you have a modulator to mix it, right? And now you have a demodulator, right? Demodulator. So now you separate them again. So this is a demodulator, right? So you separate this into 2 things, right? So you have this audio, now you have this audio frequency again. And your carrier, it's gone, your carrier, right? So you don't need it. So your carrier, and then you separate this back into this. And now you amplify it again. You have this AF amplifier again. Right? So hopefully it's a good amplifier, so you don't amplify just the noise, right? You amplify the signal. And now you send this one to the speaker now, right? Okay, so that's how you go from the microphone, right, and then to speaker, right? Okay, and then in between here you have the transmitter, right? The transmitter that transmitted out the E field, right? And then you have let me change the color here. You have the B field, right? Okay, and this is going out in the speed of light. Okay, so this is going out in the speed of light, and then in here you have the another antenna here, right? So one transmitter antenna, and here receiving antenna, right? And this one here basically does the opposite of it. Now it receives it, and now it creates this electric signal, right? So you receive the signal, you create this electric signal. All right. Okay, and then it goes through this device here. All right. So I'm going to stop here, and so see you until next time.